Types of waves. Hello friends, so today I'm going to introduce to you a very interesting topic, types of waves. In our last module, we've discussed about a wave. So how do you describe a wave? A wave can be described as a disturbance that travels through a medium from one location to another without transporting any matter. That's a point to ponder. Without transporting any matter. Do you know what a mechanical wave is? Here, I'm going to give you a brief introduction about a mechanical wave, and the detailed information I'll share with you in my next module. Okay, so a mechanical wave is nothing more than a disturbance which is traveling through a medium such as a solid, liquid, or a gas, as you've seen in the case of water waves that are formed when I throw a stone into the lake or a pond. That's as simple as that, as a mechanical wave. Now this disturbance so created in the lake is caused due to the to and fro motion of the water particles. So now in this module, we are going to discuss about the various types of waves. Like in our previous module, we have taken a situation where a group of people were standing in a queue and all of them was holding each other through their shoulders. So what did we observe over there? What was actually happening over there? When one person sits down, he pulls his neighboring person to sit down as well. And when he stands up, he again pulls his neighboring person to stand up. So it keeps on moving that way. So each person here is undergoing only up and down motion. And this disturbance is propagated towards the last person of the group. Similarly, we can take an example of a rope. So if I have a rope with me, you can see here, the disturbance, it travels through the rope. And how this is traveling through the rope? Let's see. What do you see if you carefully observe this rope? Yes, if you carefully observe this rope, then you must have noticed that the red dots, the red dots which are present on the rope, they keep on undergoing to and fro motion about their mean position. While the disturbance, it keeps on traveling forward through the rope. So what do you conclude from the above two examples? So it is concluded that it is the disturbance that is carried forward, but the particles of the medium, they are undergoing to and fro motion only, and that is about their mean position. So here the waves, they move straight from one end to the other end, while the particle motion which makes that particular wave is in a direction which is perpendicular to the direction of propagation of the wave. Now this type of wave is called as, any guesses? Yes, this type of wave is called as the transverse wave, in which the particles of the medium, they move in a direction which is perpendicular to the direction of propagation of wave. And some of the examples of transverse waves are the water waves, which are formed when I drop a stone into a lake or a pond, the light waves and the radio waves. These are all examples of transverse waves. Now let's do a simple activity to demonstrate how a transverse wave looks like. Let's take a slinky and place it on the table, and we're fixing its one end and the other end is let free. Now I hold the free end of the slinky and just whip it. What do we observe? The slinky, it appears to move like a snake, and it shows a wavy appearance. What kind of wave does this vibrating slinky represent here? Yes, we've studied this, and it's a transverse wave. A transverse wave in which the particles undergo to and fro motion about their mean position and moves in a direction which is perpendicular to the direction of wave propagation. Now we'll take the same group of people that we had taken earlier, but this time with a slightly different arrangement. And let's see what happens. So it is the same group of people, but in this case, they're not holding each other through their shoulders, but through their elbows. Now in this case, the first person, he gently pushes the second person sideways and then pulls him back. You see this push and pull moment, and this is propagated towards the last person of the group. So how is this moment different from the previous one, where each person is holding each other through their shoulders? Now that's something which we have to look forward to. You can see here in the previous case, each person was undergoing up and down motion, while in this case, each person is moving back and forth, back and forth about their mean position, and the push and pull is transmitted to the person at the end. Now consider the case of a slinky whose one end is fixed to a point. What happens? Now I give a sharp push to it, and what do we observe? Yes, you observe that some sort of disturbance is carried forward from one end of the slinky to the other end. What is this disturbance? This disturbance is carried forward while all the rings of the slinky are moving back and forth about their mean position. But the disturbance, it gets carried forward. Now if I push the slinky forward and backward continuously, then what do you see? It's another interesting thing that we observe. You see here a series of compressions followed by rarefactions, compressions and rarefactions, where the compressions are the regions where the rings are crowded together and rarefactions are the regions where the rings are far apart. So compression and rarefaction both move forward. And in this case, wave motion is in one direction, and the motion of particles of the medium are in a direction which is parallel to the direction of propagation of the wave. Now what do we call this kind of wave? This presents us the second kind of wave, which is known as the longitudinal wave, in which the particles of the medium, they undergo back and forth motion about the mean position, and this is parallel to the direction of propagation of wave. And some of the examples of longitudinal waves are the sound waves. So when I'm speaking, the sound wave which I emit from my mouth is an example of a longitudinal wave. So let's summarize till now whatever we have studied. We've studied that there are two types of waves, a transverse wave and a longitudinal wave. A transverse wave in which the particles of the medium move in one direction, which is perpendicular to the direction of wave propagation, and they oscillate about their mean position, to and fro motion. The examples were a ripple on a pond or a lake and a wave on a string. They can be easily visualized as transverse waves. Some of the other examples that we studied about were the light waves, the heat waves and radio waves. All are examples of transverse waves. Now coming to the longitudinal waves, the second kind of waves, in which the particles of the medium, they move in a direction which is parallel to the direction of wave propagation. And we had the examples of sound waves, a wave in a slinky. So these are good visualizations of longitudinal waves. So this is all about the types of waves, and in our next module, we'll discuss about sound waves in detail.